Hey, remove the preconceptions. Continue to integrate the things that we've learned as architects and engineers for the last 100 years, but then open your eyes to other materials that can be implemented. Structural engineered bamboo is crazy strong because it's not just renewable, it's rapidly renewable. We're sequestering about 35% more carbon on a similar acreage of land. And the root system stays in place, so it's a continuous process. We're only harvesting these mature poles. Our beams came in more cost effective than steel. We beat out steel, especially here in the Midwest. We beat out timber too. It was the first time a new species had been added into the standard under structural composite lumber in 35 years. It was a big deal.
This is the Mass Timber Group Show. I'm Nick.
And I'm Brady, and we talk to sustainable building experts. Today we caught up with Luke Schüette, the CEO and founder of ReNuTeq, a game-changing company making structurally engineered bamboo products for the building industry.
This was a great episode because you don't know until you know. Luke's making big waves with new and sustainable building materials, even outcompeting steel on price. Structurally engineered bamboo is impressive, and he takes us on a deep dive.
But before we jump in, if you want to learn more about building multifamily mass timber buildings and meet others doing the same, just like Luke, we're hosting the second annual Mass Timber Group Summit this August in Denver. We've got 30 plus sessions, 3 amazing networking parties, and building tours of the coolest projects in Denver. Check out the link in the show notes below for more info. And if you like these podcasts, subscribing to the channel is the biggest compliment you can give us. It helps us book incredible guests like Luke and brings more mass timber awareness to the rest of the world. So with that, let's get into it.
Structurally engineered bamboo is what we manufacture. And what is structurally engineered bamboo? Well, it is the composite of engineered bamboo slats to create structural grade components for buildings. And this is what our entire company is about. We focus on the design and integration of our materials with steel parts for buildings, roof structures, solar charging structures, and we're excited to continue to grow in this path.
So for somebody that's never heard of structurally engineered bamboo or even bamboo being used in like Western hemisphere building, why did you decide to use bamboo? Like what applications or what characteristics make it different than something that might be more familiar to other people?
Well, this actually dates back to 2003, my final year of architectural school. I met with my structures professor, and we talked about what are all these different wood fibers from glulam, PSL, LSL, all of these softwood timber products that you see. And I always had this fascination with the performance grades of bamboo and the different species and how could bamboo be implemented utilizing some of these technologies that we've been doing in this country for about 150 years. You don't think about it, but the glulam industry, dating back to Weyerhaeuser and some of these major players, we've been integrating the engineered wood process for about 150 years. So I looked at this and I thought, what if we build upon this technology, the adhesive technologies, to include an alternative species? That's essentially what the bamboo fiber is. It's a alternative species that has a little bit different cellular makeup based on its silica content versus cellulose. And we essentially looked at how this higher performance fiber could be integrated to create the products. And that's where it started.
Got it. And structurally engineered bamboo is already folded into the building codes. We talked a little bit before we started recording, and you were a part of that. Can you unpack kind of like how that journey went?
Yeah, it was an amazing process. It was in a very unique time, just even in our economy in the United States. In 2007, I did some initial testing, actually right here in St. Louis, Missouri, at a small test line where I tested some structural components that I actually made out at the family farm, gluing slats together and made these components. And then I was in communication with the ASTM executive committee, which is familiar with the engineered wood structural composite lumber. division is ASTM 5456. And that executive committee, even though I was young, they allowed me to come and present this alternative, structurally engineered bamboo product. And essentially, it was pretty intense. You know, what we had was about 8 or so people in the room. They all represented these major players in the industry that you would all know the names very well. And they allowed me to present. And from that moment, they appointed me as the chairman of this new task group, which is called the DO70203. And it sounds like it's this honorable thing, but what it really means is that you better figure out what you're doing, get your ducks in a row. You're going to be doing a ton of work, and we're going to be, cross-examining every step of the way. But it was really something because at that point, even though they allowed that to take place by nominating me into that position, I was pretty hesitant that any progress would even be made. But fortunately for me, we saw a downturn in the economy. If you remember 2008 to 2009, and essentially some of the technical bodies, were kind of slowing up. And what we did is we just hit the accelerator with getting all of our processes in place. And in fact, a major person from Weyerhaeuser, his name's Bruce Craig, was essentially a 35-year veteran, developed PSL, all these major products within Weyerhaeuser. He was given early retirement. Well, we scooped him up and he became an executive advisor for our company. And within a couple of years, we were able to add SCB into ASTM 5456 under this task group. This, like I said, the DO70203, we added SCBN. And it took a few years. This is 2009 all the way through 2012. And at this time, we also added SCB into AC47 under the ICC ES, which is the International Code Council. So at that time, we added it into these two primary governing bodies. And what was a big deal is that in 2012, when it was officially added, it was the first time a new species had been added into the standard under structural composite lumber in 35 years. So for us in the United States, maybe we didn't hear about it too much because it's kind of this small group of the nerdy engineers that are paying attention to this. But internationally, where ASTM is referenced, it was a big deal. In fact, many other countries contacted us to learn more about what had happened, this brand new material being added into the standard. So what's exciting now is when you flip open your IBC under ASTM 5456, you see structural engineered bamboo in the standard in the International Building Code.
Hey, we're going to get back to the podcast in just a second. But first, I have a question for you. Are you somebody looking to build a mass timber project? If the answer is yes, then you need to put together an experienced team.
Our partners at Cornerstone Timber Frames are leaders in heavy timber construction and have 30 plus years of experience, which means you can trust them to get the job done right.
They collaborate with Nordic Structures to bring you the highest quality FSC certified mass timber available. They also have some of the most advanced fabrication technology in the industry, so your project goes up smoothly without costly on-site modification or delays.
That means they have the experience, network, and technology to make your next mass timber project a success. Learn more about Cornerstone Timber Frames by clicking the link in the show notes below. That's exciting. I mean, in 35 years, that's just a really cool feather to put on your hat. You're blazing a new trail. And if you go to your website, which I hope people go to, it's ReNuTeq.com. And I'm looking at some of your projects, and one that stands out, obviously, me and Brady are veterans, so it already kind of, stands out in our hearts a little bit. But the Veterans Airport, the roof structure is super cool. What stood out to you with that project?
What was really interesting, I appreciate you asking about that. It was a new airport terminal. And interesting, I'm actually a grad from Southern Illinois University. We have a very strong ROTC program for airline pilots. Yes, Veterans Airport completed in 2016. We did with Popker Construction. What is really unique about that project, if you do get a chance to check it out, it is a hybrid. What you have is a steel barreled roof system, and structural engineered bamboo was integrated as X bracing. And what was so exciting about this project, not only was it right there in Marion, Illinois, which is right next to my university. So I had a bunch of architectural and structural engineering professors come and meet for ribbon cuttings, and it was on the news. And it was a big deal for the university because, in their eyes, the product essentially originated from Southern Illinois University, Carbondale, the home of where Buckminster Fuller established the geodesic dome. So they added this in as another advancement for their university in an airport terminal right there next to the university. And the interesting thing about this is that because the roof is curving, we were able to do all of our X bracing members as a curved element intersecting each other. And we assisted the structural engineer on the entire connection design and how it braced into the steel ribbed vaulted roof. And we're extremely proud of this project because it was the first time the material had been added into an airport roof system in the United States, right here in Illinois. So that was a major success. If you get to read some of the quotes from the airport manager to Packer Construction, I mean, it was absolutely seamless how our beams just dropped right in. The other key point, which we were not expecting, is that our beams came in more cost effective than steel, hot form steel, which, if you think about steel, when you start bending it and making curves, is not cheap. So this is where uniquely, even as a younger company, newer technology, we were able to actually beat out the price of steel.
Yeah, that's super interesting. Like generally, when people think about newer mass or newer technology, especially in the building industry, I mean, even look at mass timber, they're like, yeah, it's super cool and super sweet, but what's the premium it's going to cost me? It's really great that you guys are able to like outcompete like right off the bat when you're swapping out bamboo for steel. What other applications does structurally engineered bamboo play really well with?
I would say my biggest focus, as I mentioned, I come from an architectural background, and I'm always thinking about how we can build in the most high performance way. And so you're seeing an example of a hybrid application here, but my focus, one of my strongest focus and passion is glass systems. And what you see here is a cross section of a typical structural glass system or curtain wall system. And right now we're doing a project um, where we're spanning 42 feet. Now, if you're familiar with curtain wall design and you want to span 42 feet, what that means, if you're going in with aluminum, is that you need to take that large cross section of aluminum and load it with steel to be able to handle the wind loading. Or you need to build a grid work of steel behind it to resist the wind loading. Now, the glazing and facade engineers know that you need to resist a deflection of about 3/4 of an inch, the L over 240. So you have these wind loads coming in. And so how can we have something that's aesthetically pleasing, but yet still have the structural capacity to where you don't need to come back with steel to make it more rigid? Well, that's essentially what we're able to do. We're able to accomplish the structural element as well as the glass connection, all within one component. And what we obviously know, which is a great benefit of timber and other natural materials, is that this is thermally resistant. So even the connectors that are coming through the glass aluminum system are actually penetrating connecting to and fastening to a thermally resistant material, which, as you know, reduces thermal bridging. So from a performance standpoint, when we look at potentially these front end costs being X, we always want to be able to say, look, maybe we're spending a little bit more upfront, but what is your life cycle analysis? What is your operations costs? And we did a study actually with the University of Illinois Champaign-Urbana, where we were able to take a standard type of building, about 10,000 square feet, and simulate when you utilize a thermally resistant material with the R values that are associated with structural engineered bamboo, you can actually start to downsize your HVAC equipment. So these are real costs. Not only are you going to spend less money on your energy, but you can actually end up buying smaller HVAC equipment. So this is why, from a building envelope and enclosure standpoint, I'm extremely passionate about glass systems. And this is uniquely a focus of ours. Now, in Europe, you'll see timber, various different spruce, large species of timber used in glass. But what you'll see is that whenever you have something that's extremely strong, the rigidity values are close to 3 times the strength of typical timber, is you're able to reduce that cross section. Now, in a building, that's important, but on glass, it's even maybe equally, if not more important, because you want to reduce those cross sections as small as possible so that when you look at the glass, you're not just seeing a wall of beams. If you're looking at an angle, you want those cross sections to be small. So this is something I would say is probably up there at the top with full structural systems. We also are looking at structural glass.
Got it. And we talked a lot. You just talked a lot about like your operational costs, but then also very much so plays into like your operational carbon, right? The lower your operating costs, the lower demand on the HVAC, the less thermal bridging, right? Like all that plays into like the operational carbon aspect, which generally is what initially draws people into like this mass timber, structural engineering, bamboo, like these natural, organic, renewable materials. And then on that note, like we're going to switch the conversation over to like embodied carbon. Can you explain a little bit about how structurally, or excuse me, about how bamboo is grown, harvested, like what the carbon sequestration metrics look like compared to, say, a softwood lumber species?
Absolutely. You hear about specifically within LEED, you're looking at trying to work on harvest domestically, produce within a 500-mile radius, if at all possible, and have those materials implemented for the project. We are the only company in the United States, as well as Europe, that is actually producing product from our sourced materials out of the Western Hemisphere. What that means is Central South America. We're zeroed in on Colombia and Ecuador for this absolute performance species of bamboo called guarana. And when we look at that entire supply chain, which we actually control, we are coming into it with the initiative to make it as efficient as possible. So what we have uniquely here in the Midwest is the Mississippi River. We also have a lot of nice rail coming into the Midwest. So what we're able to do is optimize our logistics into the middle of the country where we produce the product. And then out from here, we have about 5 business days. Now, you asked a question about carbon. And what we're looking at is, okay, yes, timber has a great story for carbon. Bamboo also does, not only because we're producing it within a region, but also because it's not just renewable, it's rapidly renewable. And what that means is if you were to take, and I'm going to use some farming metrics here, if you were to take 1 acre of land and grow that in, let's say, southern yellow pine, you're going to get about 8 tons of usable fiber from that piece of land. If it's clear cut, you're going to use that. There is a significant amount of waste, as we all know, between 30 to 40% waste, depending on how small the trees are that are being harvested. But within that same period of time, let's say 30 years of a typical timber growth cycle, you're able to pull 14 tons of usable fiber from a bamboo farm every 6 years. So this is, when we're talking about rapidly renewable, that's what we're talking about. Carbon sequestration is all part of this. So the total embodied energy when we're producing the product is right there as far as the production costs with engineered timber or glulam, LVL, PSL, all of these engineered structural composite lumber products. But the difference is because in the growth cycle, we're sequestering about 35% more carbon on a similar acreage of land. So it's extremely renewable. It's sequestering that carbon. If we can utilize it into a project where it's a permanent structural fixture, that is carbon sequestration in its peak. And so that's essentially what's happening when we're implementing structural engineered bamboo from a carbon standpoint.
Got it. And when So after somebody harvests bamboo, does a team have to go in there and replant it?
No, this is the unique thing, and I appreciate you bringing that up. The root system stays in place, and I'm not gonna call myself like a tree hugger or something like necessarily. I love all the different species of wood. I really like exotic species of wood that grow in all these different places. Downfall though is that when you harvest a tree, unfortunately, you are incurring significant soil erosion because the root system is removed, and there is going to be soil erosion as well as ecological uh, offset with regards to animals and things that are running around. With bamboo, it's a continuous process. So the farms that we source from, the root system is all in place. We need to have mature bamboo plants, so at least 8 to 12 years old. Then we begin to harvest that on an annual basis, and the root system stays in place. So it's a continuous process. We're only harvesting these mature poles. They're seasoned, they're treated, and then milled and engineered into our product. So yeah, it's a little different process, but to answer your question, the root system stays in place.
Got it. Yeah. So there's an entirely different like carbon track, and it's not just the same as like we're planting trees or bamboo and then harvesting and repeating the cycle. Like you're continuously using that same root system so it stays in place and the plant stays alive. That's super interesting. When you so after the bamboo is harvested and you mill it and you get it on the boat up here, you guys' manufacturing plant is in St. Louis, correct?
Correct.
Right. And then what does the process look like for manufacturing structurally engineered bamboo?
Yeah, so I think that this material here, this is an example of our Radlam beam. And if you could see how it's laid out here, we're optimizing that natural curvature of the fiber, and then we're mirroring it upon itself to create stability within the beam. And so this process essentially is optimized within our facilities here in St. Louis. But what we're importing from the Americas, Ecuador, and Colombia, is this slat. So this slag, before it ever leaves Ecuador, is treated and dried to about 9% moisture content, and it's bundled together. And that is our feedstock that comes to the United States, and we engineer that together. Now, the positive side is, as I mentioned, we've taken this through the whole process within ASTM. We also are implementing US technologies as it relates to adhesives. Now, you've probably heard of many different types of adhesives, and I'm not going to list off any brand names, but this is an area that we have zero compromise on with regards to performance. Bamboo is more of a closed cell, high silica content fiber down at the cellular level. So we have to make sure we're using an adhesive that actually can bite in to that fiber. And so we've done lots of testing on all kinds of different adhesives, looked at, some adhesives that are more, considered green or whatever. The key is that all the adhesives that are in the industry right now are all low VOC, meaning below the 0.275 parts per million. It is cured within our shop. And as it goes out, that adhesive content is actually inert, meaning it does very, very little off gassing after it's cured within our shop. And so the other misconception on it is that there must be more adhesive. We must be using gallons of adhesive to make this product. But if you think about what I just said with regards to the cellular makeup being more dense, what that means is less absorption. When you have less adhesive absorption, it allows for more adhesive to stay on those face lamps. And we end up using between 35 to 40% less adhesive than even standard glue lamp and or PSL, LVL. So, but to clarify, we are utilizing US-based adhesive technology companies to supply all of our adhesives. And like I said, we have zero compromise with regards to the performance. So we're using adhesives that have the fire performance, 50 plus year track record, all exterior grade type 1 adhesives in the process.
Got it. Got it. And so you guys have like a lot of tech and research like built into this entire process because you built this basically kind of industry from the ground up, which is super cool. But outside of like the bamboo itself, like you're a real big proponent of like hybrid systems and integrating structurally engineered bamboo in with other forms of steel. Like I'm curious about the piece that's sitting on your desk behind you. Can you tell us about that open frame system?
Absolutely. Joists have been an amazing technology from their inception. What you're seeing when you go into any large span type of structure, typically, if you look up, it's going to be steel open web joists. And what we have here with an open web joist technology is typically when you want to do some nice span, you're using hot form steel and it's welded bar joists that are creating those long spans. What you end up with, though, is also thermal performance challenges, right? Because you're dealing with an all steel solution. Now, a hybrid system similar to this is in production right now and with a great company. The difference is that their top and bottom cords are just typical dimensional lumber, and they're using cold form steel with a pinned type of system. But what we're seeing here is all welded steel with the top and bottom channel is all hot form steel. And then it's actually fastened into the top and bottom cord of structurally engineered bamboo. Now, the reason we established this product is because it was requested. This product has actually been in development for more than 8 years as a hybrid. And what you're seeing is, where the load really comes in. Now it's obviously inverted. It's a vertical alignment here, but this is the bearing plate here that ends up bearing on some sort of beam. Now that could be a glulam beam. It could be a steel beam, when we look at these hybrid systems, but the majority of the load and the shear values that come into a choice like this are most heavy on the end condition. So that's why we have this completely boxed in type of scenario here. It's welded all the way around to encapsulate the structurally engineered bamboo. So all those loads can be transferred into the joist. And then you're getting all of those similar conveniences that we typically see with joists, right? So thermal performance now with the structural engineered bamboo integrated, but obviously floor to floor heights can be reduced, which obviously impacts the total height of the building. Major budget play there because the building can be a little shorter, but still have the same amount of space interior, then that's a big win from a budget standpoint. So obviously your mechanical, electrical systems can pass through the joist and making it more efficient. The major kind of separating component of this is that structural engineered bamboo is crazy strong, especially in tension. So we have the materials integrated in these tension lam integrations here on a joist, which is absolutely taking advantage of the performance fiber of the bamboo.
Got it. And like, what would be, so you talked about that lower floor height, which means like smaller or shorter buildings, but then I imagine that cost also transfers to like less facade costs. Is that true? Like, how do the costs with these systems stack up?
Yeah, I mean, this is the basic budgeting analysis and value engineering that goes into any project. How can we, have less glass by reducing our floor to floor heights, for example? The glass and exterior materials are by far the most expensive part of a building because we're resisting all the elements, the weather and air infiltration, water infiltration. So we're talking about, sealants, gaskets, and glass and aluminum, other expensive materials. So if we can obviously reduce those floor to floor heights, we're going to be, in the green with regards to budget reduction. So we're playing on some of these things that are common, great cost-effective measures that you see in a building, but we're able to integrate our materials and take advantage of it in such a way. Now, this product is being optimized with a major joist supplier here in the United States that has all the certifications, all the testing. And so when it comes to volume and spans, we're pushing 80 plus feet spans with these, and we have the capacity to do an amazing floor to floor and or roof system, very cost effective and more lightweight. obviously.
I was curious about the manufacturing of it in general. I mean, how far out are some of your lead times right now? And then, even in the same sense, was there any new technology or when it comes to like pressing this bamboo to make it work that was different compared to like, cross laminated timber or maybe like a glue lam with dimensional lumber?
Yeah, we touched on the patented process, which is this Bradley product that we mentioned earlier, where we're laminating the high performance portion of the fiber. Now, this process has been patented by myself, obviously by the company, to zero in on the highest performance fiber of the bamboo and actually remove some of the lower performance fiber. On a bamboo culm, it's a little bit different than a tree. It's the outer edge of the culm that has just a really high level of silica fiber. It's almost like glass. It's so dense. And then as you go in to the inner wall of the fiber, then it has less silica fiber. So in the patent, we're optimizing that most portion of the fiber, and we're milling it into these radial slats that then go into the final components that are implemented into the joists, into all of our structural components. And what was amazing about this technology integration is that our cost actually went down. Because if you look at the cross section of this conventional engineered bamboo product, you'll see tiny rectangles. And what you're seeing is actually a waste of the highest performance fiber. And also these slats, because they have to be smaller because you're working with a curved comb, you're actually creating more waste. So with the integration of this patent, we actually create a much higher strength product while making the product cheaper or more cost effective for projects.
Got it. And so you've got incredible manufacturing capabilities. You got the logistics all figured out. You've been building buildings since what 2009-ish, somewhere in there. Like, what are you guys after next? Is there anything that you can share with us about projects that you're working on or where you're taking the company?
Yes, we have some great projects. We are coming out of, hopefully even more so, a pretty difficult time in this country as it relates to manufacturing. Any of your podcasters or anybody out there in the business world will be lying if they said it's been easy, to do business in this climate. So what we're focused on is essentially really bolstering up our US processing and manufacturing. Now, as a newer company, we have some great industry partners from glue lam fabricators from different parts of the country, East, West Coast, Southern states. There's even a newer company that we're working with out of Arkansas. Uh, Conway, Arkansas is a great Midwest region for us to work with. So as far as scalability, that is our goal because we do have some sizable projects that are moving forward now. We have some smaller projects here in St. Louis that are great. But I would say our goal is to continue to streamline our supply chain because what we saw in the pandemic, that fretful time where commodities were all over the place, the cost of everything from eggs to timber were fluctuating. And what we have been able to do is because we control our supply chain, we established our supply chain, we were nearly impervious to some of these influxes because we were still continuing to source from the same place. Obviously, logistics plays into that, fuel costs. So there was some movement. But to continue to refine our supply chain and more operations right here in St. Louis, more automation, more robotics, as far as Hundegers and things like that, CNC processes. And we're also continuing to expand into very similar to the glass types of systems, other industrial applications. So this is where that's a major sector of our company is that we do products that are not even within the building industry. We are milling because of the performance, because of the sustainability. We're going into industrial applications where typically steel and other metals are used and replacing it, such as high volume distribution, robotics facilities, I'm unable to mention the names of the companies that we're working with, but uh, major companies are integrating this material into their operations and into their buildings.
Got it. And so going from, let's rewind this conversation, almost 2 decades ago from like bamboo not even being a part of the building code. You took it through that. You set up an entire manufacturing and supply chain. You're sourcing products from the Western Hemisphere. You're patenting new process and put it together. And then ultimately you're building buildings here in the States. Where do you go to learn how to do this? Like, what have you done or sources that you've learned from that kind of like guided you in this business journey?
Yeah, there have been some great conferences that I have been affiliated with over the years. We've been part of the American Institute of Architects conferences. There's Greenville. And I would say, as opposed to looking at, some of the standard places that, maybe some get information, I would say that, learning and immersing yourself as architects, as engineers, to look at alternative materials. That's the kind of the difficult part in our country, and myself and many other professionals in the field will continue to spec the products that they've used before. Whether it's a glass system, you have the all aluminum glass system. Which, I see all these beautiful timber structures, mass timber, and then I look close and it's all aluminum glass. Well, you're missing a huge opportunity for thermal performance to look at a hybrid glass system along with that. If you're doing all this work to integrate mass timber, let's look at other hybrid solutions to make the building fully functional and at the highest level of performance, thermally and aesthetics, and from an innovation functionality standpoint. So yeah, I mean, if you can, as people who are specifying architects and engineers to attend some of these conferences where innovation is being presented.
It's important to get out there and shake hands and talk to people. That's where it happens, is back of the napkin type of things. Well, back of the napkin type of discussions that happen just over a drink or something. And we're very excited to have you come out to the Mass Timber Group summit coming up in Denver as well. So if people can come out there and talk to you firsthand and do a little bit of back of the napkin drawing, and maybe we can get some projects going out there in bamboo as well. So we're excited for that. So, but before we ask our last question, where can people find you or connect with you and the organization?
I would say, aside from the website, which you already mentioned, I would say LinkedIn is probably the most powerful source. Obviously, you immerse yourself in some of these other platforms, it's bogged down with everything. It feels like LinkedIn, as it relates to the professional fields of structural engineers, architects, that's going to be the best path. And I would say that, you know, just reach out right to us. And, as far as what our team is made up of, architects, engineers, operations guys, we know what the process of a project typically is. I know a lot of these other companies do too, but I feel like we've really optimized our process from preliminary quoting to design assist to kitting things together in a manner that the bank understands all the key stakeholders in the project. We can pull things together very quickly, even though it's newer and even though it seems like it's different. It's all the same field. It's the same engineers. It's the same architects. Even the people who process our product, from the Hundigger operators, all the same machinery, same adhesive technologies. It's all the same industry. Even though we're looking at an alternative material, it's benefiting the entire industry. We're all getting to do more projects and more work all together. So it's not like, hey, that's not necessarily timber. No, it's all the same product, executing efficient projects together. And that's how I would encourage people to submit us a project. Let us quote it. We beat out steel, especially here in the Midwest. We beat out timber too, because we're looking at products coming from Canada or all these different places. So we can be extremely efficient with regards to the delivery. I would encourage you too to check out some of our projects. One of the ones I would showcase is the BMW solar canopy project. you know, what was amazing is that structure designed to withstand 200-mile-an-hour winds was built in one day. So one of our key elements of our company is that we get into the details from every pole, every plate. How does this thing come together? Seasoned people, including my own father, who is also an architect, gets into the details with how we detail these connections and joints and everything out to make the project go together as fast as possible and efficiently as possible.
That's awesome to hear, though, that you're able to be cost competitive and you're actually able to beat out the other traditional ways of building or even, mass timber. I think, I don't think anybody has a blanket, fix out there. There's so many different ways to build these buildings. And this is just another incredibly sustainable way and a great example to do that. So thank you for coming on. We appreciate that. Talking a little bit more. Last question. If you could wave a magic wand and change one thing about the industry, what would you change and why?
I would wave that magic wand and I would say, hey, remove the preconceptions, continue to integrate the things that we've learned as architects and engineers for the last 100 years, 200 years, even back thousands of years from masonry all the way through. But then open your eyes to other materials that can be implemented. I think that as a human race, we unfortunately kind of get stuck in things, many thousands of years we could only think of stone. Then we started thinking about steel. And now, right here in St. Louis, Nick, you talked about how you love St. Louis. Do you know that the longest span bridge is made up of 3 different materials called the Eads Bridge? And it's the only one that's still standing because it integrates cold form steel, it integrates mild steel, and stone piers coming up through the Mississippi. So obviously the St. Louis Arch is a major force of innovation. We are here in St. Louis to also bring more material technologies forward. So we feel like we're perfectly positioned right here in the Midwest. And, if I could wave that wand, I would say, look at the new materials that are coming online from timber products to hybrid products and try to implement some of these systems that are available.
Yeah. Well, thanks for coming on, Luke. I mean, this has been a super enlightening conversation. And thank you for introducing us to structurally engineering bamboo, explaining, the pros, the cons, everything in between, like your logistics supply chain, bringing it into the code. This entire conversation has just been packed with knowledge. And I encourage all the architects, engineers, people that are speccing this stuff to reach out to you and find out more about what structurally engineered bamboo can do for them. And then personally, we're looking forward to shaking hands and cheers and a beer at our conference next August. So thank you for coming on.
I'm very much looking forward to it. I really appreciate this opportunity, and I hope you have a good rest of your week.
You too.
Cheers.